Some of the most controversial inventions in history weren't dismissed because they were fully understood. They were dismissed because people couldn't agree on what they were looking at. The Orgone Accumulator sits in that unusual category. For some, it's an overlooked scientific experiment. For others, it's an example of how easily observation can drift into belief. Decades after it first appeared, it still raises the same question. What exactly was its creator trying to measure? To understand why this object continues to attract curiosity, you have to look beyond the wooden box itself. Many people first encounter the Orgone Accumulator through old photographs or documentaries. It doesn't look particularly impressive. A small cabinet made from alternating layers of organic and metallic materials. No moving parts, no complex electronics. Nothing that immediately suggests advanced technology. That simplicity often creates confusion. How could something so ordinary become the center of such intense debate? The natural response is to search for evidence that either proves or disproves its claim. People read articles, watch interviews, compare opinions, and quickly discover that the conversation rarely becomes clearer. Instead, it splits into two opposing camps. One side dismisses the entire subject immediately. The other accepts almost everything surrounding it. Neither approach leaves much room for careful examination. That is where many people quietly lose interest, not because they found satisfying answers, but because every explanation seems to come attached to a larger belief system. Over time, the object itself almost disappears beneath decades of arguments. To understand why, it's necessary to go back to the person who built it. Wilhelm Reich was originally trained as a physician and psychoanalyst. His early career placed him inside established scientific and psychological circles. Over time, however, his interests expanded beyond psychology into biology, energy, and what he believed were fundamental processes inside living organisms. This shift changed everything. As his research moved further away from accepted scientific models, skepticism grew. Critics questioned both his methods and his conclusions. Supporters argued that he was exploring ideas that conventional science wasn't prepared to investigate. Regardless of which position someone takes today, the historical record shows that the disagreement became larger than the experiments themselves. This is where the discussion often becomes oversimplified. People tend to ask whether orgone energy exists. That sounds like the obvious question, but historically, there was another question underneath it. How should unusual observations be investigated when they don't fit existing models? That question reaches far beyond Reich. Throughout history, science has advanced by testing unexpected observations. It has also protected itself by rejecting claims that fail careful testing. Both processes matter. The difficulty is knowing which situation you're actually looking at. Imagine hearing an unfamiliar sound coming from inside a machine. Ignoring it could be a mistake. Assuming you already know its cause could also be a mistake. The first step is usually observation before conclusion. That distinction is easy to overlook. As conversations about the Orgone Accumulator spread, many discussions became centered on personal beliefs instead of experimental methods. The box itself was designed according to Reich's theory that alternating layers of organic and metallic materials could concentrate what he called orgone energy. He believed this energy was naturally present throughout living systems and the environment. His supporters reported observations they believed supported these ideas. Mainstream scientific institutions, however, found that controlled evidence did not support the existence of orgone energy as described. Attempts to validate the theory under accepted scientific standards did not produce reliable confirmation. Those two realities have existed side by side for decades. Understanding that tension is more valuable than pretending it doesn't exist. The real issue isn't whether the wooden box looks convincing, it's whether extraordinary claims can be separated from the quality of the evidence supporting them. That changes the conversation. Instead of focusing only on the object, attention shifts toward the structure of investigation itself. Symptoms and root causes are not the same. Curiosity is a symptom. Evidence is part of the underlying structure. Effort is not automatically the same as a reliable system. Someone can spend years exploring an idea while still using methods that fail to distinguish genuine patterns from coincidence. At the same time, rejecting unfamiliar ideas without careful examination can also limit understanding. Those two possibilities are often presented as opposites. In reality, both require the same discipline: careful observation, clear definitions, repeatable testing, independent verification. These principles don't exist to discourage curiosity. They exist to make curiosity more reliable. The story of the Orgone Accumulator becomes much more interesting when viewed through that lens. Rather than asking whether history produced a misunderstood invention or an unsupported theory, it becomes possible to ask why certain ideas continue to attract attention long after scientific consensus has formed around them. Part of the answer may lie in human nature. People naturally look for patterns that explain complicated experiences. When existing explanations feel incomplete, alternative frameworks become appealing. Sometimes those frameworks eventually gain strong evidence. Sometimes they don't. The challenge is recognizing the difference without allowing either enthusiasm or dismissal to make the decision too early. This perspective also explains why discussions around the Orgone Accumulator remain active today. It represents more than a physical object. It represents a recurring tension between observation, interpretation, evidence, and belief. That tension appears throughout the history of science, medicine, and technology. Sometimes accepted ideas change. Sometimes they become stronger after criticism. Sometimes they disappear because the supporting evidence never develops. Understanding that process is often more valuable than reaching a quick conclusion. If this topic sparks your curiosity, a useful next step isn't necessarily to collect more opinions. It's to examine how different claims are evaluated, what counts as convincing evidence, and how scientific models evolve over time. That approach doesn't guarantee simple answers. It does provide a stronger framework for asking better questions. If you'd like to continue exploring subjects like this, you'll find a structured breakdown in the description that expands on the ideas discussed here. Subscribe if you enjoy thoughtful explorations of unusual historical and scientific questions. Thanks for watching, and until next time.